So in this lesson, we're going to be talking about functions and their graphs. And the important parts of this standard that we are going to be focusing on is talking about the key features of graphs and tables in terms of quantities. We want to be able to sketch the graphs showing key features. We're going to just kind of look at some very simple ones. We really want to make sure that we understand domain and range, and we want to just go through the basics of domain and range. So a relationship is a relationship between two sets, the inputs and the outputs. Okay, inputs are domain and outputs are range. So, for example, a set of ordered pairs has a relationship. The first number in each ordered pair are the x's, they're our inputs, and the second number is our y's, or our outputs. So there's different ways that we can go ahead and illustrate a relationship. One is a table of values. So in a table of values, we have some type of relationship between points. And for example, if we take that one up there, and I write it like this, and I could add another one. There is a table of values. Then we have a mapping. A mapping shows a relationship between two sets. This is the input, and this is our output. And we use arrows to show what correlates to what. So 0 maps to 2, 1 maps to 3, 2 maps to 3, and 2 maps to 4. So remember, we're just at this point talking about relationships. Then, of course, you can have a graph. So we could graph a line. We could have a graph that looks like a parabola. So the sets of points on this curve, every single one shares some relationship because they're on the same graph. We could have a graph that is a circle. And again, every point that's on that circle shares some type of relationship. And there's other ways that we could go ahead and represent the function, such as, a relationship. So there are other ways that we can go ahead and represent a relationship, such as with an equation. So for example, if I had the relationship x squared plus y squared equals 9. Should have known that from geometry, by the way. Or I could have a relationship such as y equals 3 times x plus 1. It's another relationship. So looking at each of these, they each have a domain and a range. So let's go ahead and figure out what they are. So in our table of values, it's pretty easy. It's just the set of numbers that make up our inputs is our domain. 0, 2, -4, 5. And of course, to put it in proper order, we should actually write it. So we have in order, -4, 0, 2, and 5. And our range is just going to be our outputs are our y's. So that's going to be -1, 1, 2, and 8. They don't have to match up when you put them in, or when you're writing the domain and range for a discrete set, such as this one, you put them in numerical order, least to greatest. They don't have to match up as far as 0 goes with the 1, 2 goes with the -1, etc. In our mapping, our domain is 0, 1, and 2, and our range would be 2, 3, and 4. Now, sometimes students find these a little bit harder to do, so I'm going to make a better circle before we actually find the domain and the range. Okay, so here's our circle. So the thing to remember about domain and range, okay, is that domain goes with x. So here's our x-axis, and range goes with y, and that is our y-axis. So right here, if you think about how wide that circle is, that kind of tells us what our domain is, because it's starting at where x is 1, and it's ending over here 1, 2, 3, 4 units later, where x is 5. So that means all our values of x, so every point that's on the circle has an x value that's between and including 1 and 5. So we would write that as 1 is less than or equal to x, which is less than or equal to 5. Another way that we could write it would be using interval notation. And in interval notation, we would use brackets 1 to 5. Okay, so for our range, we're looking at our y values. So instead of looking horizontally, we're going to look vertically. So the least value of y is going to be at the bottom of the circle, and the greatest value of y is going to be at the top. So that happens to correspond with 4 and then 8 up here. So that means all of our values of y, or our range, are between 4 and 8 inclusive. So we would write that 4 is less than or equal to y, which is less than or equal to 8. And in interval notation, it would be 4, 8 with square brackets. Now, in set builder notation, which we will be talking about, we write it like this. X such that x is between 1 and 5. Y such that 4 is less than or equal to y, which is less than or equal to 8. Close brackets. So here are some practice problems, and you can go ahead and pause and see if you can come up with a domain and range on problems 1, 2, and 5. So let's see how you did. Okay, so for number 1, you should have gotten for the domain all the values of x. So -5 is the least, then -1, then 3, then 7. And for the range, you should have gotten -1, and you only write it once because even though it appears twice, we only need to put it in our set once. Then 0 and 4. Okay, now number 2, we have to look at the individual ordered pairs. So you should have had this point was -3, -4. This point is 1, -3. This point here is 2, 0. This point here, 1, 2. And this point over here is -1, 5. So our domain is -3, -1, +1. We only have to write it once, and 2. And then our range is -4, -3, 0, 2, and 5. Now let's look at number 5. So on number 5, I see that the graph is very definitely starting right here. And then there's an arrow here that says it's going on forever. So let's look at where it's starting. So this point is -3, -4. So our domain is all the values of x that go from here to the right. Because of that arrow, we know it's infinity. So that means it's included here because of that closed circle. So it's going to be in set builder notation. We would write it as x such that x is greater than or equal to -3. And in interval notation, it would be bracket -3 to infinity, parentheses. Okay, so this is still for number 5. Okay, let's talk about the range. Okay, so now the range is starting right here at this point, but it's the values going up from there. Because this is going to go off to the side, it's going to increase and increase and increase and increase. There's no limit because of that arrow to how high it's going to get. So in set builder notation, we would write it y such that y is greater than or equal to -4. And in interval notation, we would write it as bracket -4, infinity, parentheses. Okay, let's look at a couple more examples. So you may want to try these yourselves, but I'm going to go ahead and just pick a couple that you may or may not have ever seen before. Okay, so I want you to try first. So pause, and then we'll come back and we'll go over it. Okay, so let's see how we did. So first, on number 7, there's definitely the highest these are going, and right here is the lowest. So that means all of our range is starting down here and going up to there. But this arrow and that arrow are saying that we're not going to be skipping any values of x. As a matter of fact, we're going to keep going and going and going in that same pattern. Sorry for the bumpy lines. So let's go ahead and write that. And so this time we're just going to work on interval notation. So it's easy if we're going forever to the left and forever to the right and left movements go with domain. So we're going to go from negative infinity to positive infinity. Remember, infinity always gets parentheses. For the range, we definitely have a minimum, and that's going to be at -4. And we definitely have a maximum, which is going to be at +4 every time. So we would write that -4 with a bracket to +4. Okay, let's go ahead and look at number 9 now. Now on number 9, these arrows here and here are saying to the left we're going on to infinity, and also in our y movement on both sides, we're going on forever. We're going infinitely up and infinitely down. Remember, up and down goes with range. But there's definitely a beginning point where all the point, or a terminating point, I should say, for our domain, because even though we're using all the values for x to the left of this point, once we get to here, we don't have any more values of x. So our domain is going to be from negative infinity all the way up to where that point right there is for x, which is at 0. And it would be a bracket because there actually is a point that has an x value of 0. Now we're looking at the range. Remember, we're going infinitely up and infinitely down, and we're not skipping any numbers for our range. So we would say that's all real numbers. Okay, last, we're going to look at number 11, which is a little bit harder. And if you don't remember how to do this, it's okay. This is technically called a rational function. So it's actually skipping some numbers right here in the middle, in case you didn't notice. What it actually is skipping is everything's getting closer and closer and closer to that vertical line. In case you forgot what that vertical line is, vertical lines are always x equals a number, and it's 1 unit to the left of the y-axis, so it'll be at -1. So basically, it's going forever and ever and ever to the left from there, forever and ever to the right of there, but it's skipping -1. So let's see how we write that. Negative infinity up to -1, not including the -1, in union with -1 to positive infinity. And so right here, that information is saying we skipped the -1. Now for our range, we're looking at all the possible values of y. Now just on this side, we're going forever and ever up and forever down, which means we're not skipping any y values. So our range would be all real numbers. Remember, all real numbers in interval notation, it's negative infinity to positive infinity.